There are several different ways to achieve latching using RS Logic 500. In this video, we're going to discuss the process of using internal bits for latching. So we're going to latch and unlatch some internal B3 bits on the B30 word, and then those are going to drive the output state. So I have RS Logic's MicroStarter Lite open. This is the free version of RS Logic's 500. If you don't know how to download this, please check out my other video. So the first step is we'll add a open set of contacts and a latching coil. This is an output latch or output to latch, OTL. And we're going to use an input that represents the start button. So this will be slot 1, channel 0. And we'll just call this start button and start as the symbol. Next, we're going to add a latching coil. And this is going to be tied to our first bit in the B30 word, so B300. And this will just be called internal memory bit for latching, and we'll just call it int bit. Next, we're going to add a branch around this start logic for our stopping logic. So our stopping logic will be another push button, which is going to be input 1/1 for channel 1 on slot 1, and we'll call this the stop button. And then we're going to add a equivalent unlatch. So whenever you use a latching coil, you always have to have a paired unlatch so that you can tell the PLC to turn that coil off. Otherwise, the latching coil will stay on indefinitely without an instruction to turn it off. So we'll go ahead and use the same address, B300, for that bit. So right below the rung that we just added, we're going to add another set of open contacts, and this will be tied to our B300 bit. And then lastly, we're going to add a output to energize, which is going to go to our first output on the output card, which is slot 2, channel 0. And this will just call motor out. And then we'll verify this rung, and we will save the project, and then we'll go online to test our changes. So we must place the processor in run mode to ensure that we are running the program. And now we can toggle some bits. So I will toggle the start button, and notice that when I toggle the start back to false, that the B300 bit stays true. And the reason for this is because this is a latching type of coil, meaning that we are explicitly telling the PLC to remember the state of this coil until we tell it to turn off. And the way that we turn this coil off is by toggling the stop button, which in turn activates the output to unlatch on the same bit, and then we'll drop out B300. So we'll go ahead and toggle the stop button input, and now we can see that the output to unlatch was true, which unlatched our coil and dropped out our B30 bit. So by toggling the input on channel 1 of the input card, we activated this output to unlatch coil, which dropped out our B300 bit, which turned this B300 contact off, and also turned off our output to 0 going out to our motor start command. So the reason why we use internal bits to drive the state of outputs rather than just latching or unlatching the outputs themselves is that it's generally considered bad practice to latch or unlatch outputs due to the difficulties in troubleshooting and tracking down the state of outputs when using latch or unlatch pairs. Thank you for watching, and I hope this helps.